Gomphotheriidae. Gomphotheres are any members of the diverse, extinct taxonomic family Gomphotheriidae. Gomphotheres were elephant-like proboscideans, but not belonging to the family Elephantidae. They were widespread in North America during the Miocene and Pliocene epochs, 1.6 million years ago. Some lived in parts of Eurasia, Beringia, and following the Great American Interchange into South America. Beginning about 5 million years ago, they were gradually replaced by modern elephants, apart from the last two South American genera, of which Cuvieronius did not become extinct until 9100 BP, and Haplomastodon, by some authors reclassified into Notiomastodon. Fossils have been dated to as recently as 6060 BP in the Valle del Magdalena, Colombia. These Gomphotheres also survived in Mexico and Central America until the end of the Pleistocene. The name Gomphotheres comes from ancient Greek gamma mu phi omicron, peg, pin, wedge, joint plus theta hetero omicron nu, beast. Gomphotheres differed from elephants in their tooth structure, particularly the chewing surfaces on the molar teeth. The earlier species had 4 tusks, and their retracted facial and nasal bones prompted paleontologists to believe that Gomphotheres had elephant-like trunks. Both the genus Gomphotherium and family Gomphotheriidae were erected by the German zoologist Karl Hermann Conrad Burmeister in 1837. The genera Ananchus, Morelia, Paratetralophodon, and Tetralophodon, but also the families Coeurolophodontidae and Amoebelodontidae were formerly classified as Gomphotheres, while recent work recovers Gomphotheres sensulato as paraphyletic, with Tetralophodont Gomphotheres closely related to Elephantidae and Amoebelodonts and Coeurolophodonts more primitive than Trilophodont Gomphotheres. Phylogeny of Trilophodont Gomphotheres according to Moth et al., 2016. Isotopic analyses of South American Gomphotheres suggest a wide diet for Notiomastodon platensis, except for the fossils unearthed at the localities in Santiago del Estero and La Carolina in Ecuador. Isotope analyses suggested an exclusive C4 diet, whereas every other South American locality indicates an exclusive C3 or mixed C3 and C4 diet. The results also support the latitudinal gradient of C3 and C4 grasses. The stereomicrourinalyses for N. platensis exhibited average scratch and pit values, which place it within the extant mixed feeder morphospace, and the higher frequency of fine scratches indicated the ingestion of C3 grasses. Alternatively, the presence of coarse and hypercoarse scratches along with gouges and large pits suggests the ingestion of foliage and lignifid portions. The plant microfossil analysis recovered fragments of conifer trachide and vessel elements with array of parenchyma cells, which corroborates the consumption of wood plants, pollen grains, spores, and fibers. The Aguista Araxa Gomphotheres were generalist feeders and consumed wood elements, leaves, and C3 grasses. Cuvieronius specimens from Chile were exclusively C3 plant eaters, whereas specimens from Bolivia and Ecuador are classified as having a mixed C3 and C4 diet. Notiomastodon showed a wider range of dietary adaptations. Specimens from Quequén Salado in Buenos Aires province were entirely C3 feeders, whereas the diet of specimens from La Carolina Peninsula in Ecuador was exclusively C4. The results confirm that ancient diets cannot always be interpreted solely from dental morphology or extrapolated from present relatives. The data from Middle and Late Pleistocene periods indicate that over time, there was a shift in dietary patterns away from predominantly mixed feeders to more specialized feeders. This dietary evolution may have been one of the factors that contributed to the disappearance of South American Gomphotheres at the end of the Pleistocene. Climatic change and human predation have also been discussed as possible causes of the extinction. Gomphotheres remains are common at South American Paleo-Indian sites. Examples include the early human settlement at Monte Verde, Chile, dating to approximately 14,000 years ago, and the Altiplano Cundiboyacense and the Valle del Magdalena of Colombia. In 2011, remains dating between 10,600 and 11,600 years ago were also found in the El Fin del Mundo site in Sonora, Mexico's Clovis location. The first time such an association was found in a northern part of the continent where Gomphotheres had been thought to have gone extinct 30,000 years ago. In July 2014, it was announced that the position and proximity of Clovis weapon fragments relative to the Gomphotheriidae bones at the site suggest that humans did in fact kill the two animals there. Of the 7 Clovis points found at the site, 4 were in place among the bones, including one with bone and teeth fragments above and below. The other 3 points had clearly eroded away from the bone bed and were found scattered nearby. Gomphotherium angustidens. Gomphotheres models in Osorno.